lang tayo sa salit. Ano nga ang carbohydrates? Ano chemistry ng carbohydrates? Polyhydroxy, maltodextrinol. Dahil polyhydroxylated sila, polar sila, kaya as expected, yung solubility nila nasa polar solvents. Okay? So, ano yung mga ginawa natin? So, usually, ano yung mga sample na ginagamit for differentiating the various types of carbohydrates na. Meron kang ginamit, syempre, na glucose. Meron din tayong fructose. Okay? May ginamit din tayong mannose. May ginamit din tayong arabinose. Ang missing sa atin noong mga panahon yun ay galactose. No? And then we had starch. We had glycogen. So these are the common samples na ginamit natin. Actually, hindi lang sa experiment 1, pati sa experiment 2. Dahil ang experiment 2, ang title na ay polysaccharides. Diba? Yun lang, wala tayo noong sample na viable na cellulose. Although kasama siya dapat sa experiment 2, din natin nagawa. Okay? So ano ulit ang glucose? Anong klaseng asukal? Monosaccharide, ano ba? Ano yung specific example or specific group niya bilang monosaccharide? Aldose na? Aldohexose, diba? Okay. Aldohexose. Ano ngayon yung fructose? Ketohexose. Sige. Tapos, ano pa nga? Si mannose, ganun din, aldohexose. Si arabinose, aldopentose. Si galactose, aldohexose pa rin. Starch ay, anong klaseng polysaccharide? Sige, polysaccharide ano ba? Ano ka? Tama? Sige, storage, polysaccharide. We're talking about the structure. Kasi yun ang itatest mo sa lab eh. So, anong klaseng asukal nga si starch? Homo o hetero? Homo. Homo polysaccharide. Kasi gawa siya sa glucose. Diba? May bibig unit siya ng glucose. Eh, si glycogen. Ganon din. Si cellulose. Ganon pa rin. Saan lang nagkakatalungan? Si starch, gawa pa sa dalawang unit. Amylose at saka amylopectin. Okay. Si glycogen, kamukha lang. Sino? Amylopectin. Si cellulose naman, ano? Ano yung naiiba sa kanya? Glycosidic bond. Ano meron kay starch na? Sa amylose, meron ka alpha 1,4. Sa amylopectin, meron ka alpha 1,4 at alpha 1,6. Sa mga branch point, ready pa yan, di ba? Si glycogen bale, ganito rin. So ano ang difference ni cellulose? Hindi nga siya sumusunod sa alpha 1,4. Siya ay naka-beta 1,4, kaya hindi natin natadigest. Okay? So yun. Although hindi nga natin nagawa sa ating activity. So, kung naaalala pa natin, alam ko kasi hindi ko binabalik yung data sheet, kaya sinusulat ko natin. Okay ka na? Ano yung unang ginawa natin sa ating sample na starch? Starch yung unang pinatest eh. Ano sabi doon? Doon sa medyo naaalala pa kailang pinagagagawa. Si starch, di ba? Gawa nga sa glucose. So, bale, carbohydrate. May carbon, may hydrogen, may oxygen. Maliwanag, walang nitrogen, walang sulfur. Okay? Ang ginawa ay lagyan mo daw ng soda lime sa camo-triturate. Pagka-triturate, maglalagay ka ng sample sa test tube. So, ano ang purpose ng soda lime? converts the elements in your starch into reactive forms. Okay? Kasi nga, ang starch hindi talaga ganun ka-reactive dahil organic. Okay? So, kaya tinriturate with soda lime para maghiwa-hiwalay sana ang carbon, hydrogen, oxygen at ilalagay mo nga siya sa test tube. Tapos, ano nga ang pinagawa? Initan mo daw. Okay? So, ano ang mga tanong doon? Pag pinainitan. Alala ba? Did the sample melt? Magme-melt ba dapat ang starch? Matutunan ba ang starch? Hindi. Diba? Did the sample give off smoke? Ha? Oo. Bakit? Kasi nagiging water vapor yun. And in the intense form, it can be smoke. So, meron. Okay? Did the sample caught fire? Yes or no? Sa tingin nyo, starch? Pwede magliyab? Hindi, di ba? Hindi siya flammable. So, hindi. Okay? Did the sample give off odor? Oo naman. Sinulog mo eh. Di ba? It will be smelling like burnt rice. Parang sinulog na kanin. Di ba? Starch yun eh. Did the sample change in color? Yes pa rin. Tama? Kasi, bakit nag-change color pag iniinitan? Ano nga ba kulay ng starch pag iniinitan? Ha? Ano na? Ano ang itsura ng kanin na sunog? Nangingitim. Bakit? Dahil sa anong element? Carbon. Di ba ang carbon itim? Coal. Okay? So may change in color dahil sa charring. Again, ano yung charring? So, chem. Deposition ng carbon. Di ba? Deposition ng carbon. Nag-cause ka ng formation ng char, coal. Okay? Kaya may change in color. Yun lang. Ano ba pinagawa? Kung naaalala, kukuha ka daw ng filter paper, i-moisten mo daw ng lead acetate. Okay? And this is the formula for flumbus acetate na, or lead acetate. No? Para saan ang anything na may soluble na lead? Pang-check mo kasi yan ng presence ng sulfur. Okay? So, doon sa mga nagtatanong sa amin ng experiment 1, ano ba dapat ang makita mo sa filter paper ko na may lead acetate? Dapat wala. Kasi nga, wala siyang sulfur. Okay? Pag may sulfur ang sample ko, naglagay ka ng soda lime sa sample mo, kunyari lang may sulfur siya, yung sulfur na baon, magiging hydrogen sulfide gas. So, pag ininitan mo yan, mag-e-evaporate siya, yung filter paper mo nasa ibabaw. So, yung sulfide, magre-react sa lead, ang ending, magiging lead sulfide na precipitate na kulay brown to black. Okay? And then, ilagay lang natin yung byproduct, 2 molecules ng acetic acid. Binalance ko lang. Kung kayo ay pansinin sana. H3COO, tapos 2 hydrogen, ayun. And then, yung lead nag-react sa sulfur, naging lead sulfide, so, naging brown to black precipitate. Ano dapat ang ma-observe mo sa filter paper kung meron ka sulfur? You'll be seeing dark spots sana. Kung may sulfur. But then again, your carbohydrate na does not have sulfur, so there should be no change on the filter paper that is moistened with lead acetate na. Okay? So yun ang reason doon. Tapos ano pa yung tanong? What is the color of the residue? Syempre, it's black. Okay? And then what is formed daw at the cooler end of the test tube? Syempre, moisture. So, this is just confirming the presence of carbon, hydrogen, oxygen. Kasi moisture is, of course, water. So, tinest ko lang po ang ang general elemental composition ng iyong carbohydrate. Pinalidate ko lang na may carbon, may hydrogen, at oxygen. Yun yung purpose ng procedure 1. So, kalimutan yan. To check for the presence of sulfur or sulfide, dapat reagent of choice, lead acetate. Lagi. It's always lead acetate. Okay? So, yun na. The rest is already easy. Kasi we have discussed them in the lecture part. Nauna pa sa lecture, no? So, ano yung what are the common tests na, or what are the tests na lang that we have done for the carbohydrate? Una, polish. Polish. So, refer to your lecture again. What's the positive result na? Polish. Purple ring. Di ba? Purple ring. No? So, ano yung pinatest? Starch, glucose, sucrose. So, all of them should give the positive result. Why? Kasi again and again and again, polish nga is a general test for carbohydrate. So, all of your carbohydrates should produce the violent ring at the junction of two liquids na nga. Sa Tagalog, generally, kahit anong carbohydrate, madedetect niya. Okay? Or magpapassive siya. O, what's the second test nga? Unrolled. Unrolled. And it's the same samples to be tested, so you are expecting the same result. All will give the positive result. And what is the positive result nga ulit for unrolled test? Green-colored solution without precipitate. No? So, all three of your samples should also give the positive result. Yun lang. So, the first two tests were general tests nga. The next test was Benedict's test. Okay. Benedict's and Nylander's. Ayan na. What's the difference again between the two? And what's the similarity? Similarity muna. Both are used for testing or detecting reducing sugars. Okay. And what are the reducing sugars na ulit? Monosaccharides. Tsaka all disaccharides except sucrose. And also may halos. Sige, buti naman may nakatanda pa. So, yun ang ina-expect natin. Those are the samples that we are expecting to give a positive result with Benedict's and Nylander's. All monosaccharides, okay? And all disaccharides except sucrose. So, if you are to test nga, starch, glucose, lactose, sucrose. Okay? What are the expected results? The starch will give negative. Kasi it's a polysaccharide. Okay? Glucose will give, lactose will give, of course, sucrose will give negative. Then what's the positive result ulit? Paulit-ulit. For Benedict's? Break red precipitate due to the formation of one compound nga. Cuprous oxide. Diba? How about Nylander's? It's the same pa rin. It's the same. Kasi this is also a test for reducing sugar. The only difference is what nga? What reagent is being used? Bismuth. Sap. Nitrate. Bismuth, sap, nitrate. Okay? So how did I come up with the formula? 3 hydroxide is negative 1 times 2, diba? Negative 2. Nitrate is negative 1. Your total should be 0 kasi, diba? By rule. So, Nylander's. What's the positive result nga for Nylander's naman? Black. Why are you seeing a black precipitate? Because bismuth is being reduced from positive 3 to metallic bismuth And you should have seen, sana, a black precipitate na. At the bottom of your tube for glucose, lactose. Okay? And if you tested fructose, syempre, fructose should also give a positive result. Kasi again, all monosaccharides are reducing sugars. All disaccharides are reducing sugars except for sucrose. And all polysaccharides naman are non-reducing sugars. Okay? May nalimutan tayo. Nag-solubility testing nga rin pala tayo. Tama? Solubility testing ito una. Solubility test for starch. In which solvents are we expecting starch to dissolve? Will it dissolve in water? Starch? Water soluble ba si starch? Oo naman, yun nga lang, you need to heat it. Okay? How about acid? How about base? Is it soluble? Sumasagot ba? Ano ginawa niyo ba? Mabili ng daan. Ang starch, pag nilagay sa acid, malulusaw? Yes. Base? Yes. Why? Kasi starch is being hydrolyzed. Okay? And if starch is hydrolyzed nga or digested, what is the product? Ang starch pag nabiyak, ano mabubuo? Saan ba siya gawa? Glucose nga, di ba? So, after dissolving it in acid and base, what happens? We produce glucose. And what is glucose? Is glucose water soluble? Siyempre, di ba? Kaya nadi-dissolve. Iulit ko, starch is soluble in acid and base because of hydrolysis. Once it's hydrolyzed, it is converted to glucose. Glucose is polar or water soluble. Starch does not dissolve in benzene. Starch does not dissolve in this solvent. It also does not dissolve in that solvent. It also doesn't dissolve in such solvent. So, sino-sino to? Pangalan? Ha? Chloroform? Sige. Ano pa? Other name? Or care? Yun. Trichloromethane. Kasi it's only having one carbon, di ba? How about this? You might call it, sige, tetrachloromethane. Kasi again, methane is the ORChem name for one carbon. 4-chloro, di ba? And it's also popularly known as carbon tetrachloride. No? If you ask it from Cathy, the label of the reagent is carbon tetrachloride nga. But yes, you can also call it tetrachloromethane. Hexane is not polar. Ether is also not polar. Okay? What's the general formula nga for ethers? Diba? ROR. So, all of this, benzene, chloroform, tetrachloride, hexane, ethers, all of them cannot dissolve starch. Kasi nga, starch is polar. And these solvents are non-polar. So based on the 3 experiments nga lang that we have done, which sample should dissolve here? Hindi ko tanong ko sa pag-alam naman. Sa 3 experiment natin na ginawa, sino yung sample na ine-expect natin na malulusaw sa non-polar solvents? Asukal o taba? Taba. What lipid sample did we use? What lipid sample did we use under experiment 3? Coconut oil, linseed oil, cottonseed oil. All of those are lipids. How do you define a lipid again? Lipid. Esters of long chain fatty acid, fatty alcohol, and if the fatty acid is unsaturated, your lipid is a liquid. And therefore, it's a mixed oil. Diba? Your fatty acid is more of saturated, then your lipid is a solid and is a fat. Fats are solids, fixed oils are liquids. No? So yun. Minention ko na. Coconut oil, linseed oil, cod liver oil, any fixed oil that you can think of can be solved in non-polar solvents. This is why we also call these solvents as fat solvents. And according to your analysis one teacher na, what is the best solvent for fat? Diba? The best solvent for fat is hexane. Sabi ko nga, mabilis magpapayag. Ilog ka lang hexane. Kaso toxic siya. Maderets ka muna bago ka pumayag. Yun ang problema. Okay? So sabi natin noon, nung analysis 1. Best solvent for fat is hexane. Okay? But it's toxic. So tayo tumigil sa testing. Polish, anthrone, Bentley's, Nylanders. Okay. Number 5 na, no? Sorry. Continuation ng mga tests. Music acid test. So, music acid test is very specific for galactose. Yun nga lang, unfortunately, we were not able to yield or produce good positive results. So, it should have been galactose and lactose as your sample, but we didn't have a good sample of lactose. Majority high, expired na, unfortunately. So, we focus on galactose, at least we tried kasi we were missing nitric acid. Remember, the reagent of choice for music acid test is nitric acid because you need the strongest oxidizing acid. And I hope you can still recall nga na when galactose kasi is being oxidized, it is converted nga to galactaric acid. The common name nga lang for galactaric acid is music acid, which will appear in your evaporating phase as what? What's the positive result? Ayun po, characteristic sandy crystal sana. Kaya lang, hindi nang na-produce ng marami, itim na crystal ang na-produce. Kung naalala nyo, the fuel. Okay? So, what do you mean by uric acid? From lecture. Ano, pinag-naragan sa libon? Ano? Pag-uric. Oxidation at carbons. Parehas, 1 and 6 sila. 1 and 6. Kasi if it's only 1, uric acid, if it's only 6, moronic acid. Sige. What is the alternative to Benedict's test? Common alternate to Benedict's test. Felix. And what's the positive result? Same lang. Frequent precipitate because of the formation of cuprous oxide. So, di ko na simulan yung Felix or Felix. Ito na tayo sa dapat alam na alam up to now. What is the purpose of this Leonov test? It's for differentiating ketones from aldose. Okay? Because it can only give or yield a positive result with ketosis. And it's the most popular test nga to differentiate fructose from glucose. Okay? Kasi your fructose is ketose, your glucose is an aldose. So what's the positive result nga ulit for Seliwanox? Red colored complex or red colored solution. So glucose should be negative, fructose should be positive. Question, how about sucrose? Can sucrose give a positive result with Seliwanox? Yes or no? Yes. But you have to digest. Why? Sucrose is made up of glucose and fructose. sucrose. So if you digest sucrose, you will get glucose fructose. Fructose is present and therefore can give you a positive result. Diba? So pwede mo positive ang sucrose. Okay? Provided that you digest or hydrolyze first your table sugar. Next meeting, quiz na lang. Everything that we are to discuss today. Next meeting, quiz in the laboratory. Sorry na. Kasi 2 weeks na lang, midterm na naman. Kasi nyo ba? Okay. Bials. For what is the bials test nga? For pentoses. And we only had one sample nga to test, and that is arabinose. Di ba? So, ano nga ang arabinose ulit? Aldo, pentose, sige. And what's the positive result for bials test again? Oo, no? Green colored solution. With or without precipitate, but usually na with a precipitate. Okay? So, arabinose. And then, we need the osa. Ginawa nyo nga ba? Ang osazole. May nakita naman tayong crystals. Sana. Ito. What carbohydrates can form osazoles na? All of your monosaccharides na naman. Most common one would be glucose, fructose, and mannose. From your lecture also, no? Amongst the three which rapidly produces nga the osazoles, mannose. Did we have mannose ba? Kasama sample? Ako wala. Pero wala. Si Johnny lang yung buo o the rest of it. Iba yata ang school. Tingin ko. Okay. So, yun. Mannose. No? Mannose is the most rapidly formed osazole, but the other case, you are not able to use it. All disaccharides can also form an osazole. So, wala. In case I fail to emphasize in the lecture, osazole formation is a test for all mono and disaccharides. Lahat. No exception. Unlike for reducing sugars, sucrose is the exception for reducing sugars. Sa osazole, wala. Lahat ng disaccharides mo can form an osazole. Okay? Oh yeah, that's it. Those are the only tests that we were able to do because of the agent availability. And then for experiment 2 naman, it's quite easy. By the way, the latter part of experiment 1 is related na to experiment 2. And experiment 2 is all about polysaccharides. So what are the common polysaccharides encountered in the laboratory na? We have starch, which we obtain from potato. I hope you can still recall. Glycogen, which we obtain from liver. And then, yun nga, we didn't have the purest cellulose as sample, no? But usually, we can obtain that from cotton. Na pure sana. Okay? Unahin na natin si cellulose. There's only one test kasi for cellulose. And the thing is, sayang, we don't have it right now. Back then, we had it, Schweizer's reagent. So what is the Schweizer's reagent? It's the only reagent that can dissolve cellulose. So why am I saying sayang? Kasi if you have cotton or even filter paper, are you familiar na filter paper is made up of cellulose? Yung pinag-filter nyo, cellulose din yan eh. Okay? Yung nga lang, we didn't have the Schweizer's reagent. And yes, it can dissolve the filter paper. Nakakita na ba kayo ng filter paper na nalulusan? Bulak na nalulusan. Nakipan. O yun nga, sayang. Diba? Black tayo. Anyways. the Schweizer's reagent. Kasi it can dissolve cellulose. Okay? Yeah. So what's the common test na for starch and glycogen? Glucols or any iodine-containing solution naman. Di ba? So, what happens nga? If you add starch with iodine, you form deep blue. Di ba? Why is it deep blue? Kasi iodine reacts with saan nagre-react ang iodine? Sa amylose o sa amylopectin? Sa amylose. Okay? Which is not water soluble. And iodine is also not water soluble. How about glycogen? When it reacts with iodine, it forms a deep red color. Okay? So, if you could recall somehow the simple things that you did, experiment 2 was simple. The only hard procedure is extraction of starch from potato and extraction of glycogen from the liver. Sa Tagalog, madali lang yung 2. Nagpatagal lang sa atin doon yung pagkuha ng starch and glycogen. So, ano pinagawa niya? After adding glucols, ano sabi? Urine. What is expected? The color should be lightening. Okay? The deep blue color for starch should have lightened. The deep red color for glycogen should have lightened too. Okay? Why? Kasi DNA can partially digest polysaccharides. So, glycogen and starch. What are the components again? Ulit-ulit lang. Ano naman ang dalawa? Laging glucose. Diba? So if you heat them up, a part of the starch can be digested or can be converted to glucose. Meaning to say, you are losing part of the starch. That's why you're losing part of the color. Okay? Ganun din for glycogen. You're heating your glycogen, so you're losing some parts of your glycogen molecule. So you're losing some parts of the different color. That's why it's lightening nga. Okay? Oh, ano pa pinagawa? What's the next thing it required you to do? For starch, you add daw NaOH. For glycogen, you add daw hydrochloric acid. Okay? So what will be produced? Ito lagi yung tatandaan na. Strong base, strong acid. Ano gagawin niya sa mga biomolecules mo? Sino lang, pag kumain ka ng starch, na-expose sa HCl, ano mangyari? Pag kumain ka ng glycogen, na-expose sa HCl, ano mangyari? Matadigest. Laging ganon. So starch, upon treatment with base, is converted to glucose. Glycogen on treatment with acid is also converted to glucose. Because these are the degradation products of starch and glycogen. That's why the colors that you're seeing are now gone. Diba? Your deep blue solution becomes colorless, sana. Your deep red colored solution becomes colorless, sana. Okay? Sana ganun nga yung lumabas. Why? Kasi glucose is not reactive with iodine. So your experiment 2 is all about detecting the presence of starch and glycogen and digesting it to glucose. You just validated it, okay, through the disappearance of the color. And then what did you do pa? Ayan, dami nagtatanong sa akin na, Sir, what does this mean? The hydrolysate, treat it with, test it with Benedict's, test it with fillings. So what is Benedict's and fillings again? Test for reducing sugar. What is glucose? Reducing sugar. So, what's the purpose of the last step? Of testing your hydrolysate or product of hydrolysis with fillings or Benedict's nga. It's only validating nga, di ba, the presence of glucose.
Okay? So, if you add, let's say, Benedict's reagent, okay? You are expecting a brick red precipitate. Okay? So the essence of experiment 2 is validating the presence of starch and glycogen and validating also that they are made up of glucose. Yun lang yung essence nun. Okay? Now, if you notice also, no, when you are heating your starch and glycogen, sige, it tightens up. But if you cool down your sample, what happens? The color is being restored. Bumabalik sa dati. Okay? Kasi, in the absence of heat, the glucose molecules within starch, within glycogen, can reform glycosidic bonds. Nabubuo ulit yung starch-glycogen. Kumbaga, if you remove them from heating, okay? That's a natural tendency for your polysaccharides. And that is experiment 2. Ganun lang kaiksi. Last experiment na tayo, experiment 3. Ngayon na kaya tayo mag-quiz, no? Ha? Short quiz lang naman. Hindi na dadagdag next week kasi sabi niya dami niya raw quiz next week. Experiment 3 title is, siyempre, lipids. Okay? So, the common lipid samples available to us were coconut oil, cottonseed oil, linseed oil. In your pharmacognosy, were you able to use this? Ay, pharmacognosy tuloy. Dosage forms? Di pa. Candiver oil? Di pa. Okay. Anyways, what can you recall about, sinabi na pala natin kanina, sorry, gulo ko. Oils are what nga? Liquid lipids. Because they are made up of, ano nga? Esters of unsaturated fatty acids and fatty alcohols. Okay? And the formula for esters would be RCOOR. And remember, the lipids are what? Lipids are, ano nga? Usually triesters. Kasi the most common fatty alcohol nga is glycerol. How many alcohols does glycerol have nga? Tatlo. And the alcohols are the points of attachment for the fatty acids. Okay? So, susulat ko pa ba? Solubility test again. Sulat ko nila yung solvent. Will it dissolve in water? O, let's say coconut oil. Will it dissolve in water? Hindi. NaOH? Hindi rin. Kasi NaOH is in aqueous solution. Aqueous solutions always have water. And lipids cannot dissolve in water. How about acid? Hindi pa rin. Lipids cannot dissolve in acids. But lipids can dissolve in, yun na nga, the best solvent is hexane, although we didn't have it in the lab. It can dissolve in chloroform, it can dissolve in carbon tetrachloride, it can dissolve in benzene, it can dissolve in whatsoever ether. And again, that's the reason why we call this fat solvents. Dapat alam, fat solvents. Okay? So yun, that was the first test that we did for our lipid samples. No? Oh, what's the next test? Yung marker na naman. Ano na yung sumunod? Oo. Spot test. What is the spot test? You put a small sample of your lipid on a clean sheet of paper, ideally white. And when do you say it's positive? If it leaves a permanent translucent spot nga. if you cannot imagine po, let's say this is a bond paper, you put a small sample of coconut oil, the coconut oil stays there. Kasi nga, fixed oils are non-volatile. The spot test nga is for differentiating fixed oils from volatile oils. So what are volatile oils nga? I know you know kasi these are the first experiments in your dosage forms, di ba? Ano experiment pa ng dosage forms? Ito nagkakamali. Stronger rose water. USP. Di ba? Nakikita ko kayo, may petals pa kayo tinadali. O, anong laman doon? Volatile oil. So what's the difference of volatile oil from fixed oil? From a physical standpoint, syempre, that's why we call it fixed. They do not volatilize. Volatile oils, they are volatile, obviously. By the way, what's the synonym of volatile oils? Ethereal oils, kasi they are very soluble in ether. Okay? And from a chemistry standpoint, volatile oils can contain various functional groups, kahit kung naisulat. Volatile oils can contain aldehyde, can contain ketone, can contain esters, can contain phenols, can contain phenolic ethers. They can also contain hydrocarbons. The point is they may contain different types of organic functional groups. How about esters? How about fixed oils? They are always esters lamang because fixed oils are lipids. On the other hand, volatile oils are not lipids, but they may contain esters, although the esters being contained po are not fatty acids and fatty alcohol. So sinabi lang natin, ang fixed oil natin laging ester. Volatile oil, hindi mo pa-sure. Depende pa yan eh. Okay? At pwede sila magkaroon ng ester, pero hindi gawa sa fatty acid, fatty alcohol, kagaya nung sa fixed oil. Yun yung malaking difference. And the differentiating factor for the two, to detect the presence of the two, you do a spot test nga. For fixed oils, you'll see a permanent translucent spot. For volatile oils, if you put a sample of your volatile oil, no, and let it dry up, literally, it will dry up. Literally, it will dry up. It does not, or they do not leave nga a permanent translucent spot kasi they are volatile. Yun lang naman. Okay? So what's the most common fat alcohol ulit? Ulit. Most common fat alcohol? Glycerol. How do you detect the presence of glycerol nga? Diba? O yan. No, yun nga lang, most of you got negative. I'm not sure why. Maybe it's the reagent na naman. That's another problem. So, what's happening in the accolade test is, you have your glycerol. And you are to heat it up in the presence of potassium bisulfate. At na-discuss din natin ito sa lecture. What happens is the carbon 1 becomes an aldehyde because it's being oxidized. Carbons 2 and 3 are dehydrated. Dehydrated or removed of water. Okay? So, oops, mali. 1, 2, 3, 4, 1, 2, 3, 4. Okay na. So this is now your acrylate test. It should give off a pungent odor or irritating odor. Kaya lang, most of your samples came to do so. Okay? So this is now your acrylate. What's the IUPAC name nga ulit? 1, 2, 3. So that's propene. Propene kasi that's 1, 2. You have a double bond at carbon 2. So propene. But it's also an aldehyde. So propanol. Okay? Dapat pala, sorry na, tinatanong pa rin sa boards. Propanol, acrylate. So, if you are able to smell a pungent odor, then it's a good sign that you have glycerol in your sample. And if you have glycerol in your sample, then you're sure that there is a lipid sample. Okay? So yun. Propanal is the systematic name or IUPAC name of acrolate. Sabi natin noon pa sa lecture and also part care. No? So yun. Yung ginawa natin, yun na. How do you test for the presence of sterol? Wala, paulit-ulit ko tinatanong sa atin, gusto pa na, ano. Okay, how do you test for the presence of sterol nga? Dalawa lang naman yun. Di ba? You have Lieberman-Burchard, otherwise known nga as acetic acid sulfuric acid test. Okay? So, what's the positive result? Red to blue to bluish green. And yes, I know, most of you can only see blue. Some of you naman can see the bluish green. It can vary kasi talaga. Okay? So, if you have noticed sana, no, we didn't have acetic acid. What reagent was used in place na? So, sinabi ko rin ng lecture na pag wala ka acetic acid, you can replace acetic acid with acetic anhydride. Kaya another synonym would be acetic anhydride sulfuric acid test for sterols. Okay? Ano pa? Test for sterol. Siyempre, isa pa. So this is number 1. Number 2 nga is Salkowski. Synonym? Sulfuric acid test. Okay? So again, you have your sample, you place cholesterol, you dissolve it in chloroform, then you slowly add sulfuric acid, and there should be separation nga. And it can vary. What do I mean? It can happen po na your sulfuric acid appears here. Sometimes your sulfuric acid appears at the bottom. Most of the time, it's at the bottom sana. And your chloroform, most of the time, should be at the top. So what happens nga to the acid layer? Green fluorescence. Sana. I know some of you were able to see the green fluorescence na at the top part. Okay lang naman. Kasi on agitation po, the two systems of liquids can interchange between each other. Okay? So your chloroform naman will be assuming what color na? Bluish red first, sana, to cherry red, to purple, or violet. Okay? And last but not the least, what other test did we do? Yung nagpapaka kayo, pa isa-isa. Hindi, okay, isa Tuesday. Tapos na tayo sa test for sterols. What other test did we do? We did the iodine value by using Ubel's solution. Ubel's solution contains iodine. That's it. The samples that we used were linseed and cottonseed. Okay? So, dun sa mga gumawa, kung naalala pa, you were required to add Ubel solution, drop by drop, to your linseed oil, and then, afterwards, you were also required to add Ubel solution, drop by drop pa rin, to your cottonseed oil. Okay? So, you don't have to know the exact number of drops, kaya lang, which is expected to require more drops of iodine. O ano nalilito ba sa resulta nyo? Ano? Linseed, dapat. Very good. This will require more drops. Pangit yung ganun. More drops of UBEL solution. This will require less drops of UBEL solution. And so what? What will be the implication? Ano ibig sabihin nun? Kasi diniscuss na yan ang analysis 1 teacher yun eh. Kaya kung may makasagot ngayon, pwede natin i-accept sa kalahati ng quiz. Nino? Ha? Mas mataas yung unsaturation ni linseed. Ano yung sabihin ng unsaturation? Simulan niya eh. Ano? Ha? Nawala. Sayang. Ano? Ha? Ano? Carbon bonds? Ha? Double bond? Sige. Tapos, so you are now saying na linseed oil has more double bonds. Yes or no? Ayun dalawa. Linseed has more double bonds. Yun ba gusto nyo putahan? Hindi sila confident eh. Ano? Ituloy nyo na, andyan eh. Nag-teamwork na. Ano? Ano na? Hindi, ito muna. Ito muna. Sakyan natin yung train of thoughts nyo. Sabi nyo kasi, unsaturation. I asked what is unsaturation. You said more carbon bonds or more double bonds. So you say the linseed oil has more double bonds. Yes? Yes? Wala gusto ko sabihin? O may pinagsasalita. Ayaw mo na. Ano? Oh. Oh. So. Yes din. Anong yes? Mas maraming double bond. Okay. Ano yung implication? Eh, tatlo. Oo nga. Kung more drops of UBEL, sige, more double bonds, more unsaturated. More unsaturated. Anong implication? Ano problema? Problema ba yun? Is it a problem or is it an advantage? Nadiniscuss sa teacher niya sa analysis 1 kasi. Kaya ako pinili ka ako ibigay. Huwag ka namin kailangan ma-accept sa kalahati. Ayos ka, di ba? Diba? Di na ba? The higher is the iodine value, the higher na is the unsaturation. Tama yun. Okay? The more drops of UBEL solution consumed means it has more unsaturation. Or it has a higher degree of unsaturation or more double bonds nga. Okay? And from analysis 1 na, what is the UBEL solution? It's for determining na the iodine value. So how do you define muna the iodine value? It's the number in grams. Nasa post-lab report nyo, di ba? Kakabasa nyo nga lang. Number in grams of iodine absorbed. But as I have said in analysis 1, the term should have been added to the double bond. Because your double bonds nga found in whatsoever organic compound can be literally added with iodine. Whenever the double bond added upon by an atom. Di ba, sabi natin ng Orchem pati, basta addition ang reaction, nawawala ang double bond. Okay? So, if iodine is absorbed or added to the double bond nga, it simply means na the more iodine consumed, the more is the double bond. Di ba? And therefore, the more is the degree of unsaturation. So, it's the number of grams of iodine absorbed by, usually it should be 100 grams of fat, fixed oil, wax, resin, balsam. Sabi nga ng analysis 1 teacher nyo noon. Okay? Or whatsoever complex organic substance related to fats. So the point here is, at tatandaan ko lang, kumbaga, iodine absorbed nga yan. And the more iodine is being absorbed, the more unsaturated is the fat sample. Going back to my question, is it good or bad? Is it good or bad? Kung mataas ang iodine value or mataas ang saturation, okay ba yun o pangit? 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 Is that good? Again, the more unsaturated is your fixed oil, okay? The more it is to become a dry oil. Fixed oil yan eh. Remember that fixed oils, they should not dry up nga. Okay? Now, if you are highly unsaturated, or if your oil is highly unsaturated nga, then it will become a dry oil. And you don't want that kasi it's a fixed oil and it's drying. It should not be the case. Diba? Dapat hindi natutuyo yan. Fixed oil eh. Okay? So, looking at the two data, which is better as a fixed oil? Ayun. Kaya in your dosage forms nga, or drug delivery systems, you will be discussing cottonseed oil as one of the 4 official fixed oils that you can use as solvents for parenterals. Ano ulit pag parenteral? Ano yung enteral? Enteral. Enteric canal. GIT. So what is parenteral? Anything parallel. Parallel to the enteral. Injection. Injectable. Okay? Oo. You can use solvents such as fixed oils nga. Or you can use fixed oils as solvents for injectables. And you have 4. You have cottonseed, you have sesame oil, you have corn oil, you have peanut oil. Ano yung sinabi ni Sir? 4 ang common na solvent for fixed oils. Oh, sorry. 4 ang common na fixed oils na pwede solvent for parenterals na sesame, corn, peanut oil, and cottonseed oil. And yes, they are fats. All, they are liquids. Liquid liquids. Okay? Ay, nandun. Okay na, you will. So, sana klaro yun na UL solution, no? Pag marami ka nagastos sa UL, ibig sabihin, marami kang double bond. Marami kang double bond, ikaw ay unsaturated, ikaw ay dry oil, pangit. Pangit yun. Okay? And you have research questions there, tama? Na is actually in the lecture. O what are the essential fatty acids daw? Linoleic, linolenic. Ano rin ang tawag natin? We call them vitamins or vitamin F. Okay? Linoleic, linolenic. And what are the functions nga? Structural elements, eicosanoidal biosynthesis, ano pa? Decrease cholesterol levels, they prolong clotting time, they have fibrinolytic activity, and deficiency can cause liver cirrhosis and eczema-like dermatitis na. So what's the second research question there? What is the medical importance na of elevated cholesterol? It's the major risk factor for ano? Ano nilagay nyo? Major risk factor or elevated serum cholesterol is a major risk factor for coronary atherosclerosis. Is the specific medical term. So, atherosclerosis nga is narrowing of the artery. This time, it's the coronary artery of the heart itself. No? So, sclerosis kasi narrowing. Athero is artery. So, atherosclerosis nga is the common problem with elevated cholesterol, and atherosclerosis can cause decreased oxygen supply to the heart, leading to myocardial ischemia. And the problem with ischemia, sinabi ko rin na, ischemia is depletion of oxygen supply. Remember, blood delivers oxygen. So if the coronary artery has been narrowed na, less blood goes to the heart, less oxygen goes to the heart, and therefore you call it ischemic heart disease. Ito rin yun, ischemic heart disease. Basta ischemia, tapos sa oxygen. And what's the common symptom of ischemia nga? The common symptom of ischemia is angina pectoris. And what is angina pectoris? Squeezing chest pain at the left side for the precordium. What is the precordium? The area directly above the heart. Diba? Anatomy, pathophysiology, dinidiscuss yan. So, when do you feel the chest pain? When do you feel the angina? When you usually exert physical effort for not more than 5 minutes. Sa Tagalog, pag umakyat ka ng stairs natin, okay, ng diretso, 5 floors, pag sumakyat, stable angina. Stable angina. Okay pa yun. Stable eh. Ang mahirap kasi, sumasakit siya nang wala kang ginagawa. That is unstable angina. And the thing with unstable angina, it easily progresses to heart attack. Unstable angina is emergency. Okay? It's an emergency case. Stable angina is not. So yun, cholesterol, kaya natin gusto ipaka, ultimately, to prevent this, so that we can also prevent this. Ulitin ko, angina is not a disease, it's a symptom of ischemia. Okay? Paborito tanong yan ng pharmacology teacher nyo. Yun lang. And then, what's the other research question pa? What is the common complication of cholelithiasis nga or gallstones? Nasa lecture din, di ba? You will recall, that's the episode that I had way back in 2014 nga. Gallstone, what's the common problem? Pancreatitis. Diba? Pancreatitis. So, yun lang. We say next meeting. At gusto nyo ngayon. Break muna tayo. 20 minutes. Then we proceed with the lecture.
Thank you.
Pinta ko nakakasal.
Sorry po.
Wait lang.
Wait lang, mamaya. Hindi yan. Ano hindi ito? Game yan.
Para po yung tinatanong mo sa na attention. Basahin mo. Basahin mo ko. Basahin mo.
Sinulat ko nga kanina. Tapos mo? Hindi pa. Hot.
Ay,